On this third example, let's look right here. Notice that y squared minus 5 are not like terms, are they? So I cannot follow my order of operations. I cannot combine that group together. But I can use the distributive property to break over that. So I'm going to do the negative 3 times the y squared. That's what this says. And I'm going to do the negative 3 times the negative 5. And that's what this says. So what I'm trying to do is I'm going to do those both separately. And now I can simplify because now it's not like terms. So what is negative 3 times y squared? Negative 3y squared. And what is negative 3 times negative 5? And it's positive 15, right? Positive 15. So if I've got positive, I'm going to put a plus sign. Positive 15. The original order of operations tells me that I need to try to do the group first. But because this group is unlike terms, I can't. But I'm lucky enough that I recognize I can use the distributive property with the 8 right here, and I can break over that order of operations, and I can do that instead. So I'm going to take the 8 times the 2 and the 8 times the negative x. That's my first thing that I'm looking at. So what is 8 times 2?
16.
It is 16. And what is 8 times negative x? Negative 8x. Okay? Now, most of this that I just wrote down here, that normally happens in your head. But I did write it down to show us what we did. Now, this original x up here, I haven't touched it yet, have I? So it's still here. All right. And now I'm in a combining like terms situation, like we were yesterday. So, are there any like terms?
Yeah.
What are the like terms?
X or
The x's. So I'm going to say the x and the negative 8, and just highlight those. Okay? Those two go together. So what is 8? Excuse me. What is 1 minus 8? That's 1 minus 8x.
-7.
Negative 7. So that's negative 7x. And then what about the 16 there? Is that a like? No. So I just leave it plus 16. So you see we've actually combined two things together. We've done our distributive property, and then in addition to that, we've combined like terms. That normally with my order of operations, I would want to do the groups first. But am I allowed to add x plus 4? No, they're not like terms. So that leaves me a little bit stuck. I can use the distributive property to bypass that order of operations. What am I going to distribute? Okay, I'm going to distribute the negative 2 to both the x and to the 4, right? So even though we don't normally write this down, in my head, I'm doing negative 2 times x and negative 2 times 4. That goes on in my head. So help me with that. What is negative 2 times x? Negative 2x. And what's negative 2 times 4? That'd be negative 8. Notice there is another group that I'm stuck with. I can't add those together. So instead I use the distributive property again, and this time I'm going to take the negative 3. So I'm going to take the negative 3 times the x and the negative 3 times the 2. So even though we don't normally write this down, in my head I'm doing negative 3 times x, and I'm going to do negative 3 times 2. And that's what goes on in my head. So let's put it on paper. What is negative 3 times x?
Negative 3x.
And negative 3 times 2?
Negative 6.
Negative 6. Okay? Now, I did those in two different colors to show you that it was two different distributive properties. But now I need to take a look at what I have here. I'm not finished. Do I have any like terms from yesterday? I do have like terms. What's a like? Okay, the negative 2x and the negative 3x are alike, aren't they? So let's put those together, and let's add them together. What is negative 2x minus 3x? Negative 5x. And do I have any other like terms? Negative 8 and negative 6. Together, those go to give you negative 14. And are these two alike?
No.
No, so I need to stop, and that's my final answer. That we recognize that in front of this parentheses, there's actually a negative 1. And if you want to, some people prefer to actually put the negative 1 there and make it negative 1 so that you can see that it's there. Now you know what you're distributing. You're going to distribute a negative 1 to both of those. So in your head, of course, you're doing negative 1 times x and negative 1 times 4. So help me out. What is negative 1 times x?
Negative 1x.
Okay, that's negative 1x, and I'm just going to put it like that. And negative 1 times 4?
Negative 4.
It's negative 4. And then we do have the 5 at the very front, so it looks like this. Are any of those alike?
Yes, sir.
What's alike?
5 and 9.
5 and the 4. So I've got 5 minus 4, and my answer is going to be 5 minus 4 is 1
X.
minus x. As a quick reminder, you already know that area is going to be length times width, right? So that's not a big deal. It's not new. So look at number 1. That's as easy as it can get. What's your length and your width?
5.
Okay. I'm going to call it length and width. Actually, I think I'm going to call it base and height. Is that okay?
Yes, sir.
Because that makes more sense with these being height. So if I call it base and height, they're length and width. Anyways, length and width. What's 4 times 5?
21.
20. So the area of number 1 is 20 units squared. I'm not going to deal with the units, but it's 20 units squared, right? Maybe it's square inches, centimeters, whatever. Okay? Keep that in mind, and let's look at number 2. What's the area of number 2?
7.
It's 7m.
Yes.
Okay, good. 7m. Go ahead and find the area for 3 and 4. Guys, I just want to quickly remind you about the number 1 algebra mistake of all time. X times x is x squared. X plus x is 2x. Number 1 algebra mistake of all time is people getting those two mixed up. All right, so let's be careful with that. Rectangles. The first one, what's the area of this first rectangle?
4x.
4x. Everybody agrees with that. What's the area of the second one?
12.
It is 12. Where did 12 come from?
Because the 4 goes over because it's
Because
so
they
much
have
that
the
side.
same size.
That's right. Even though it's not written, isn't this a 4?
Yes, sir.
So this is also a 4. So keep that in mind and go ahead and look at 6 and 7. Find the areas. But I want you to go back and look at number 5 for a second. If this first rectangle is a 4x and the second rectangle is a 12, what would the two rectangles put together
4 plus 12.
be?
40AX.
It'd be 4x plus 12. If you add the two rectangles together, it'd be the 4x plus 12. The 4x is the first one, 12 is the second one. It'd be 4x plus 12. So this is the total area, right?
Yep.
What would the total area of number 6 be?
7a plus 63.
7a plus 63 would be the total area. And what would be the total?
Oh, man, keep messing up. Oh, shoot.
What would be the total area of number 7?
X2 or x squared times plus 2x.
Okay. And guys, that's really where we're going with this, is we're trying to find the total area of things. Let's look at the two line segments.
9x.
Not 9x, that'd be multiplication. It's going to
Not
be
plus x.
plus, it's going to be x plus 9. How long would the line segment beside it be?
X
If
plus 4.
X plus 4.
this little piece is x, this little piece is 4, so together it's x plus 4. And on number 10, the total line segment would be A plus 2. Okay? Number 11 is one big rectangle, right? How tall is the rectangle?
5 inches.
It is 5 inches or something, right? 5 something. How long is the rectangle?
7x.
No.
X 7 plus X.
Okay, x plus 7. Good. So it's 5 by x plus 7. Right?
Yeah, it tells you right there.
And it does tell me that's exactly how you find the area. 5 times x plus 7. In other words, length times width, right? Length times width. It's going to be 5 times x plus 7. But we also know we can divide that thing up into 2 smaller rectangles, right?
Yes.
Just tell me the area of the first rectangle.
Oh.
It's 5x, okay? And I got to zoom in here. This is 5x, isn't it? And what's the area of the second rectangle?
35.
35. So what's the total area?
5x.
5x plus 35. So can you see the distributive property there?
Yes, sir.
Okay. Now, try the last one on your own. I want you to write it as the area as a product. So you have to give me the length times the width. What's the length times the width on 13? What's the length? A. And what's the width? A plus 8. And that means my total area is going to be what? What's this first one?
Plus 8a.
Very good. This is a squared. This is 8a. So it's going to be a squared plus 8a. All right? All right. I'm looking at time. I want to make sure everybody's got an appropriate amount of time. We're going to go ahead and flip it over on the other side. There are 6 or 8 problems on the bottom, but we're going to skip them. Or we're just going to skip them. All right, so flip over to the other side. Here's what I want to do. The first 8 problems, or 6 problems, excuse me. The first 6 problems, I ask you to model the distributive property. Right? I can't use this. I need a blank. Blank, blank, blank. All right. It says model the distributive property using the area and rectangles. So I've got All right, here we go. I've got 10 parentheses negative 9 plus 5n. Okay? Now, in reality, using negative numbers in area doesn't make a whole lot of sense. Okay? But the process is the same. So here's what I want to look at. It says model the distributed property with area of rectangles. So this represents length times width. So I've got length times width. So I'm going to draw myself a rectangle. And what's the length of my rectangle? How long is this rectangle? It's 10. So I'm just going to mark it as a 10. Now the width is actually divided up into 2 smaller pieces, isn't it? All right. So what I'm going to do is I'm going to divide it up into 2 smaller pieces. And I'm going to say this piece is negative 9. And this piece is 5n. Do you recognize that negative 9 plus 5n is the total length of the top of this rectangle? Negative 9 plus 5n is the total length of the top of the rectangle. Now, this would be a model. And now, to find the answer, I just multiply. So, find the answer. How big is just this square, or rectangle? That's negative 90. And how big is just this rectangle? 50n. So obviously the total area would be those two together. And that would be the answer, negative 90 plus 50n. That's what I'm looking for on 1 through 6. On 7 through 24, you do not have to draw rectangles. You can just do the regular old distributive property and show your work.